In this example, we have Caitlin, and we are told she's a certain distance east of the school entrance at this particular time. And then she's at this particular position east of the school entrance at this particular time. And we are asked about her average velocity. Well, we can define these quantities. The average velocity, this 346.7, that's her initial position. The 312, that is her initial time. And later we have the position at an instant later in time. And this is the time an instant later. We could draw a number line to help us visualize physically what's going on. Set up our coordinate system. We can make that positive and negative. And we'll make east positive and west negative. And we'll put a 0 in. And that 0 represents the school entrance. Now, where is she to start? She's at 346.7 meters east of the school entrance. And that is her starting position. And we know that occurs at 03:12:52.3. And then a little later, she's at 328.4. Well, that's here. It's closer to the school entrance, 328.4 meters. And that is her instantaneous position there. And the time that occurs is 03:14:18.3. And of course, she moved from the start position to the final position. So that's our full-blown picture. And now we can do our givens. Well, we know y0 is 346.7 meters. And we have y. She ends up at 328.4 meters. And then we have our initial time, which was 03:12:52.3. And the final time, which was 03:14:18.3. We're looking for the average velocity. So now when we go to write our formula down, we have the average velocity equals delta y over delta t. And if you look at our givens, however, we do not know delta y, nor do we know delta t. So we have to get more specific. What is delta y? Well, it is y minus y naught. And what is delta t but t minus t naught? So now we can substitute values into that equation. So y is 328.4, and y naught is 346.7. And our final t, well, this is where we've got to look at these numbers more closely because we recognize this is hours and minutes and seconds, and we even have decimals of seconds. And of course, we might notice then that the hours are the same, but the minutes are different. So this is another case where we have to convert minutes in seconds into seconds. So we'll start out and say we have 12 minutes times 60 seconds per minute. And that is going to give us 720 seconds. 12 times 6 is 72, times 10 is 720. Plus, we have another 52.3 seconds. So that gives us 772.3 seconds. So we are going to define that now as 772.3 seconds. And now working with the other number, we have 14 minutes times 60 seconds per minute, which is 840 seconds. And we have another 18.3 seconds. So that gives us 858.3 seconds. Now, what do we do with those numbers? Well, now we have a t and a t0. So we can put those in. We have 858.3 minus 772.3. Bringing all that down, we will first do the numerator. 328.4 minus 346.7. 328.4 minus 346.7, I believe. 346.7. 346.7. That gives us negative 18.3. Negative 18.3. Minus 18.3 meters. And now we have 858.3 minus 772.3. 858 minus 772.3 gives us exactly 86 seconds. But you notice that 0.3 and that 0.3, we knew these to the 10th place. And we subtract this, even though the calculator is telling us 86, the difference is really 86.0. We knew both of those numbers to the 10th, so we know 86 to the 10th. And that's tricky. So that is 86.0. So we have our numbers substituted in, and now we can calculate our answer. And we have, and this is a beautiful thing we can do with Desmos, is we can click on this one up here, and we can hit enter, and then we can hit answer divided by 86. Type in that other number. So you can see then it gave us a negative 18.3 over 86, which is negative 0.21279. So we did our calculation, substituted values, it calculated and recorded the unrounded answer, and we've got units, so we're good. Next, we have to figure out the number of significant digits. Well, if we're careful all the way through, this 18.3, that has 3 digits. And this 86.0 has 3 digits. So that means the final answer would have 3 digits. 0.212. And this 7 then would cause that 2 to round up. So our average velocity is negative 0.213 meters per second. So that is expressed to the correct number of significant digits. Now our last question is, can this also be explained in scientific or expressed in scientific notation? And the answer is yes. We can move this decimal place over 1. And what that number looks like when we do it then is negative 2.13 times 10 to the minus 1 meters per second. And that is the average velocity. We box that answer. And how we can check ourselves that this 10 to the minus 1 is correct is 10 to the minus 1 is 1/10. And so if we multiply this by 1/10, we're going to divide by 10, which will make it smaller. And the real answer, 0.213, is smaller than 2.13. And this is our final answer for the level 3 question.